All right, so we had our decision time, or decision point. Have to figure out what type of developer we're going to use. Let's talk about those developers then. Let's see, decision point. So we could have a wet developer. So if form B or C developer is used, the developer is applied while the part is wet. It's applied while the part is still wet. I don't like my notes that I didn't like to do. So what is form B? And what is form C? I know they're wet, so that's going to be water suspendable and water soluble. Make sure I get them correct. Did I go over the forms yet?
Yeah.
Yes.
I think B is suspendable.
Soluble.
There we go. Form B, water soluble. Form C is
Suspendable.
which one has to be shaken and stirred?
Suspendable.
Suspendable. All right, so form B or C is used. Where was I here? Well, still wet. And developer time is how long?
10 to 120?
Developer time is 10 to
120.
120 minutes. If we want to do a dry developer, that would be if form, should be A or this time I'm going to put E, within a parenthesis I'm going to put D, depends. Form A or D is used. The part is dried first. And form A is dry powder. Form E or D is non-aqueous. Or solvent-based. Solvent-based. Why do I kind of do the E and the D right there?
Because they're interchangeable.
They are. Some books have the E for use for the type 1 and D for the type 2, and but Zygo kind of shows them, or Magniflex shows them as the same. All right, then we are down. Let's talk about drying. Drying. All right, so you don't have to have an oven. It may be air dried. Or maybe oven dried. But if you're going to use an oven, we want recirculating air
At 160 degrees.
at how much?
160 degrees.
Very good. Max temp, 160 degrees.
No, that's max temp? What was minimum?
Max temp. Max temp.
What's minimum at that?
Well, if you can air dry it, minimum would be anything.
Okay.
Do not over dry. What does that mean?
Don't over dry it. Don't dry the penetrant. Don't go on the electric when something's in the
You don't want to heat this thing up to 160 degrees. You shouldn't have to pull it out and wear gloves. Although sometimes they're a little warm and you might have to, but the point is don't leave it in there and just let all the penetrant cake get cakey and dry. So you just want it, you're not trying to heat it up and dry the penetrant, you're trying to dry the part from the water wash. Let's see. Don't know why I kind of threw this in after the fact. But we'll find out. So drying, circling back around, because I wrote it like this. If form A or D/E, I'll do that, is used, apply developer. Oh, I know why. Because we dried it. Now we're doing, so if, we see decision point on developer, wet or dry. Well, if we do the wet, then we're going to do that with the wet developer. You can kind of ignore the dry developer. And then we're going to dry it. And then now it comes out of the oven. If we didn't use a developer and we dried it, what comes next?
You apply the developer.
Then we have developer. So if we've, I hope I didn't confuse anybody. Did I confuse anybody?
Oh.
Huh? So remember we had a decision point. Decision. If we use dry developer, which is form A or form D/E, we dry it, then we put the powder on. Or we use the aqueous and then dry. Everybody follow? So we're kind of circling around saying, okay, now we've dried it and it's time for developer. So my two dry developers are A or the DE developer. And how are we going to put it on? So the application applied by, I'm going to do this. Form A is applied by, because it only applies that. We can sprinkle it. Immersing, blowing on, or automatic machine. Ours is kind of a mixture of the automatic and blowing. It's not automatic, it's manual, but it does blow it on. And it kind of sprinkles it too. So ours is all three. Yeah. Developer time is? How much?
10 to
10 to 120 minutes. What comes now? Now, no matter what form we've used, the developer is now on. What comes next? Okay. Inspections. So we are doing type what? Type 1, which means must use a black light. Black light specs must be checked. Kind of intermixing the process specs here. But we must have black light specifications checked. And this is done every single day. And the reason why this is important, it goes back to the old style lamps that got very, very hot. And I keep saying mercury vapor. I'm not sure if that's exactly what they were. But the lamps got incredibly hot. And when you turned them on, it took about half an hour for them to fully come on. And if you shut them down, you had to wait for them to cool before you could relight them. So if you lost power flickered off and then back on for a second, that light's dead and it ain't coming on. So you can leave it on all day, you're not going to do anything. You got to shut it off, you got to wait till it cools, then flick it back on. But the problem with those lamps is they would slowly diminish in brightness over time. But you would get used to it. Till one day you're just kind of like working with it, you're like holding the lamp real close, you don't even realize it. So it's important that you check that the light specs are appropriate. So number one, we can't have too much white light. So we have to have the maximum is what?
20 lux, 2
2 foot candles, or 20 lux. Would you like to know exactly what 2 foot candles? I almost forgot about my. So this is how you calibrate your light meter to verify that you are getting 2 foot candles.
Yep, you get a candle.
Oh, nice. 2 foot candles.
You gotta be kidding me. I was not expecting you to do that.
Three?
They surely do, that's what I'm
So you
saying.
light those, your meter should say 2 foot candles. So the maximum white light is 2 foot candles. All right, we're gonna make sure we understand that's the maximum, because it's not the minimum, right? We want it dark. You can't have much light. And by the way, well, I've done this with everybody except for Group C. I actually show you what is a foot candle. I have a little birthday candle. I light it. We hold the meter about close to a foot away, and it registers 1, so it's close. So the max white light is 2 foot candles. The minimum black light intensity is 1,000 microwatts per centimeter squared. Measured at 15 inches from the light.
So do the LED ones diminish over time too?
I don't know. I do not know.
Yeah, what is it? Like, it's just a light with like some type of like gel over, like a filter thing, or is it actually the
The old style ones definitely are, because they talk about every day you had to check your filter for cracks and stuff. Now, I don't get this, why cracks in the filter are so dangerous to you. I'm like, why? Without the filter, it's just a white light bulb. But
UV light
Ah.
filter.
But yes, it's just a very dark purple filter. I could show you with some of the even older lights, because I've had to change the bulbs in these before. It's just it's not it's a special bulb. So, all right, let's see. Inspect the part, and we've talked about that, and then interpret indications. So. Interpret the indications. We can have false indications, true indications. I don't think I did this one. I could do it real quick. Some people talk in true and false. So you could have a true or false indication. So a false indication would be what?
not a real crack?
Fingerprints, failure to wash.
Wouldn't it, this would be like similar to a false positive?
Yeah. So if it's true, is it non-relevant or relevant? If relevant, is it a flaw? Or is it a flaw which is non-rejectable? Or is it a defect, which is rejectable? And last but not least, our step is clean part. Clean the part, you use a penetrant, apply anti-corrosion, preserve the part. We could really add in one more step, and that would be paperwork. because you do need to document what you did. I learned this back in my ambulance driving days. They said, if you don't write it down, you didn't do it, which worked to my favor a lot. Did you poke that person with a stick? Did I write down that I did? But that is pretty true in aviation. If you didn't write it down and document what you did, then you didn't do it. So make sure you write it down and document what you did.
What happens if you miss, like somehow somebody misses something but they did do it? Can they like retro, like put it like something in like a logbook or like whatever?
You mean like you forgot to write down something?
Yeah. What if it was like, oh shit, like you know what I mean, like is there like a procedure? It's gotta happen.
Oh, I didn't know it was
Oh,
going
yeah.
to 6 months ago.
Absolutely. You know, it could happen. Like I did the annual on my airplane or something, and I put a new tire on, and I wrote the whole entry, and I sign it, and I put the sticker in. I'm like, oh crap, I forgot. I put a new tire on. How did I not remember to write that? Because, you know, we don't often write down things as we're doing them. I mean, I do, usually, with the discrepancy list. Yeah, you can just write the same date, tack time, something else, and just put install tire. Just add another entry. I don't see a problem with that. Just go back and do it.
Like an update to your.
Yeah. But in this didn't go in an aircraft logbook, what I did here. So if you're doing NDT work, you're probably doing it for a repair station, and in a repair station, everything lives and dies by your work order. So the work orders are actually part, it's funny, we laugh because in the repair station world, especially when you're doing component work, everybody wants their yellow tag. Like, you know, they're bringing a cylinder or a crankshaft, and like, I want this overhauled, and you know, and you do it, you know, and you'd have this like nice work order, it had all this stuff that was done, and return to service statement on the work order, like, where's my yellow tag? You know, and so you give a yellow tag, which simply just says, reference the work order, and they're like, oh, my yellow tag. They'd laminate it, put it in a very special spot, then take the work order and basically crumble it up and throw it in the glove box of the car. I'm like, the yellow tag just referenced the work order that had everything. So anyway, but what we would do is we just had, it was kind of cool the way we did it. It wasn't my idea, but all of our NDT was done on blue piece of paper, light blue paper, for whatever reason. It was the boss's idea, so we just had, maybe might have green and blue, I don't know, but they were our inspection reports, and they were just all pre-printed out. So because we could do that, it's like, you know, for Lycoming engines, it had all the components and parts and what the parameters that we did it with, and so you just check what you did, accept, reject, and you can initial it. So it didn't take long to do. All right, we good with this?
Yes.
All right, let's just take a brief look at type 1 method, Bravo and Delta. What's different about Bravo and Delta?
Most fires.
All right, so type 1 is
Fluorescent.
fluorescent. And it is post-emulsified. What does post-emulsified mean?
Emulsification you just added after the
You're adding an emulsifier later. It's not built into the penetrant. So, let me see. This is not true. I think it's the base penetrant. The base penetrant is the same as method A, but does not have an emulsifier. Sure, emulsifier. Wait a minute. My notes say the penetrant used is, oh, okay, scratch that. I just couldn't read my writing. I'm like, oh, I couldn't believe it myself, but. I know, just do that. Doesn't work anyway. Things all frozen up here.
I love that. It does, actually.
Now it's like a
Law.
word game.
All right, the penetrant is the same for both B, and D. But it is true, the penetrant does not have an emulsifier. It is not the same penetrant as method A, for obvious reasons. Hey.
It says B and D on it.
Yes.
Is there a benefit to not having the emulsifier in the penetrant?
Yes, there is a benefit. There's also a not benefit. So, all right, let's see. I'll be a little bit more brief with this. So the steps involved.
So you're saying it's the same, like fluorescent
B
material?
and D is the same. They look the same.
It's the like glowing liquid you're talking about.
Yep, still type 1.
But it doesn't have an emulsifier.
Still fluorescent, but it does not have an emulsifier.
Well, so you can't wash it with water?
So you cannot wash it with water.
Okay.
So I can put that, not water washable yet. Yet.
Yeah, whoa.
It's gotta be.
God, I can't wait to get there.
Stay tuned. All right, so our steps involved. Steps, all right. 1, what's first step?
Wash the part.
Clean. All right, same procedures. Make sure the part is clean and dry between what temperatures?
50
50
and
and
100.
125. Did I say that before, 125?
Yeah.
Yeah,
50 to
50
125, okay.
125.
Next step?
Apply penetrant. Try.
Apply the penetrant. How are we going to apply the penetrant? Spray, brush, dip, pour, whatever we want. Sprinkle, sure. 3, what comes next?
Dwell.
Dwell, how long are we going to let it dwell?
10 minutes.
10 to 120 minutes. If it's in the bath, no more than?
Half the dwell time.
Just throw it in the tank for an hour, go on lunch, and then come back.
Yeah, take all damn day to do it.
No more than half the dwell in the tank. Let's see. What comes next?
You know, wash it off, or you have to figure out how to emulsify it.
There we go.
Add emulsifier.
Okay.
Yeah, I figured
So
that
the
out.
next thing is, it's kind of weird. Remove excess penetrant. We're going to do a water wash. But this will not remove all penetrant. Imagine if you were trying to wash, you dip something in oil and tried to wash it off. What are you going to get left with?
Scuds.
A part with a bunch of oil film on it. So now we're just going to get this part that's kind of green and has all this oil film, green film on it, but it's just not coming off. So what we're going to do next? So now we're going to apply an emulsifier. And this is done with either a dip or spray only. No brush. What happens if you use a brush?
You're gonna
This
get
part?
it into your.
Well, so basically what's happening is, well, we've got our part. Come on.
All right.
Nice.
Pitiful.
I know if I hit Control Z, which is what I keep doing, it
That could
actually
be
locks
the
out the
part.
computer. Can't be around. Okay, so we apply our penetrant. to the part. Penetrant to the part. It's on top of the part. And then what's going to happen is we are going to, I didn't do that. It's got a mind of its own right now. Oh, is that what we're going to do? Okay, sure. Sure. All right. So you got the penetrant on here. Okay, apply penetrant. Then we are going to water wash. And the water wash is going to take off
All of it.
all of it, some spots. Some of it. It just seemed like such a great thing to do. Apparently this program does not work like I want it to. Okay. I want it to work. What if I just keep making it do that?
Color white over it.
Yeah, there you go. Good job. That's brilliant.
I'm so smart. I know.
Really?
Thanks.
Okay. But now I need a white pen. Where am I going to get that?
They still no color.
That's good enough, yeah.
Okay. All right. So then we're going to water wash, which is going to remove some of the penetrant, the excess, right? Okay. Then we're going to, if we want to put emulsifier. And the emulsifier is going to attack the penetrant from the surface down in time. So if I were to use a brush and brush it on, what am I doing?
Oh, you're pushing it down farther?
Pushing it down and agitating and mixing it all up. So that's not good at all. So this should have
You're gonna get all streaky or something.
should have some sort of indication right there. There we go.
Wow, that was really good.
I know.
That looks really like something that will be in the book or something.
Okay.
You're gonna want the A.
So we put an emulsifier.
I already don't have an A here.
An emulsifier on it. There we go, thank you. And this is the tricky part, is timing that emulsifier. Now, I've never personally used this particular method, but in NDT school, we talk about, they didn't even let us do it there, how you need to have, the process is actually a trial and error process. Like, okay, 15 seconds of emulsifier was not enough. 30 was too much. Okay, now try it with 20 seconds. And that's kind of how it was done. So
seems kind of weird in aviation, like where it's just like this is a lot of trial and error for.
yeah, but you're trying it with a sample part. Until you write the procedure, then the procedure is written, then you know what to do.
Okay.
The part you know is correct, so that way.
Yeah.
Well, I don't understand why there's so many methods that some of them seem like they're way harder, but they're just using the same materials that
Some
other
of
ones.
them are
It's like,
way
why
harder.
would you choose one of these ones that's
Well,
so difficult to do?
I drew this crack for a reason, and I could have went like,
Yeah. What'd you say, Kevin?
oh no.
Oh.
Please stand by. Maybe my notes should not be as long as they were.
Just because we're so ahead. We're
That's
so
right.
good.
Just talking amongst yourself. Okay, so then what happens is, all right, so if we had maybe a deep crack like that. Fill that in, maybe like that, fill it in. Okay, and so we add the emulsifier, and now the emulsifier, based on time, should do something like this. But think about the method A that we did. Would you have both of those indications, or would the method A have cleaned out this one?
They probably would have cleaned that one out.
Yeah, see, now you're going to get this indication here. You can get much wider indications, discontinuities to show up, because the emulsifier hasn't reached down to the bottom of it.
Oh, so then if you have to do this on a test part, you have to simulate what cracks you're looking for?
You can, and they make test panels and stuff that you can do this for. You just do the process. I could imagine it like this. If you're doing crankcases all the time. Well, you just do a sample with a crankcase material, and if you did one section of it at, say, 15 seconds, and you were done, and it still got a green film like you did nothing, and then you did the next one, you waited 20 seconds, it was just not quite, it was almost gone, but not quite, you went 25 seconds, that's to the base metal. So you then figured out based upon that. So I think they have it kind of figured out how much it should be for the most part. I don't think it's quite as trial and error as I make it sound. But maybe it is. So all right, so we have to dip or spray. We cannot brush it because the brush agitates it and will kind of ruin it. Let me see. Emulsifier attacks a penetrant, but in theory only the surface penetrant. This washes away the surface but leaves the penetrant in the cracks. More sensitive than type A. So penetrant only to the surface. Of the part, assuming you've done it correctly. This washes away penetrant on the surface, but leaves penetrant in the cracks. Discontinuities, if you will. More sensitive than method A. There are two types. So we have lipophilic, which is method Bravo. The emulsifier is premixed. Maximum emulsifier time is 3 minutes. Just to give you an idea of what we're talking about.
It's like making white tea.
Let me see. You then wash off the emulsifier slash penetrant, and they go to inspection, obviously under a black light. And I'll put this note, the reason why I put this is to give you a difference between why would I choose B versus D. And Rolls-Royce does not allow method B. They're strictly a D. It's apparently the lipophilic is not sensitive enough for what they're looking for. Then we have the hydrophilic.
Which is
Method D. Delta. This is the most sensitive. Works for very shallow cracks. The inspector mixes the emulsifier to control sensitivity.
I'm assuming that's a level 3.
They're the one that are going to set the process. Level 2 follows it.
Okay.
Not that it matters, but concentration is checked with a refractometer. Which is a little kind of a sight thing, and you have a little prism on the end, and you put the drop on there, and where the light comes through, it gives you the concentration, and we're looking for a concentration between 5 to 33%. So after we've put on the emulsifier, we've waited the appropriate time. So if we're doing the lipophilic, it's pre-mixed, you put it on, you time it, you wash it off no later than
3 minutes.
3 minutes. What happens if you wait too long?
It's all gone.
It goes all the way down. What happens if you don't wait long enough?
It's still there.
Yeah, it's like you didn't do anything. Or we can do the hydrophilic, which the inspector is going to give us a concentration amount, which will then dictate the time amount. So that's why I don't have a time on here. And then at the appropriate time, what comes next?
Washing.
Hey, we're going to rinse the part, washing. Rinse part, same as method A at this point. Now you're just washing off the penetrant and emulsifier all in one shot, same as method A. What comes next?
Dry? Or determine which
Yep.
developer you use.
Apply developer, I guess.
So developer decision. We're either going to apply wet developer, which is our method or form water soluble. Which one is soluble?
B.
So form B, and then dry, or we're going to dry and then apply dry developer, which is form A or DE. Next, inspect. Then,
Determine what the part is.
yeah, do all that, and the clean, and then paperwork.
Well, then inspect and clean. Right?
What's that?
Wouldn't it be well, then inspect, then clean?
Yes. Yeah. I just abbreviated. All right, let's see what we got here.
Fancy cans.
All right, let's see, we did that, what was this test called?
The Ishihara.
Ishihara, that's fun to say that word. I think I'm gonna name my dog that, kinda like saying it, Ishihara. All right, these are crack panels, but I think we talked about these, that you can buy. They're stupid expensive.
Those little things that we were using in the.
I made those.
No.
I was gonna say, like, you gotta be kidding me.
I bought some, I bought 10 of them for $750.
What the fuck,
Hey.
dude?
Yeah, not these. These are way more than that.
When we get to see
up on
this.
Etsy, man.
Yeah.
Make some money.
Well, if you can make it, please do. I'll buy them from you.
Dude, I'm not even gonna be an aircraft mechanic.
So this one right here is a
Brakes,
weldment. So it's a welded plate that was purposely cracked and sold that way. And so this is type what over here on this side?
Type two.
Type 2. All right. And type 2 method what?
D. Or sorry, that's the
Try.
Solvent washable. So the method. We'll try again. So it's not A,
Not D.
not B, and not D. So it must be
D.
D. All right. And because we've used a type 2, you can no longer use
Type one.
type 1.
So it better be
Okay.
bad.
Over here on the right side, this is type
One.
1. And you don't know the method because it's just type 1. Could have been anything. I think this was method A, which makes it, in fact, I remember it was method A. Water washable. And we don't know what developer I used on
How
that.
do you know that first one was type C? Is it always type C with type 2?
I don't know of any water washable visible dyes. They might make them, I've just never seen them. And how do I know? Because I literally am the one who did this. And I was there.
So then our guess was like pretty much just a crapshoot, huh?
We have not discussed anything about a water washable or a post-emulsified red dye. So that would have made it C. It's the only thing we've learned. So this one on the right, I think I've already talked about a little bit. It's, oh, good. Somewhere, I think I have the panels here. There they are. These panels right here. And what they are, it's kind of interesting. They're really cool. So half of this is chrome plated, and the other half is very rough, like it's been glass beaded. And then they punch it. So you can see the different punches right there. And so what they do with these cards then, and the reason why it's half chrome plated and half rough is so that you're washing it at an intensity level that would wash it off a rough surface. And then what is left are these star finishes. And you actually get, I think they're called Sherman cards. You actually get a certified card with these indications, and then your indications using your system must match what the card shows you that proves that your process is working. So this is the process control for this, is to verify that. So this has to look like that. And you can see all the sizes and stuff. How much are they? Oh, no, I think this one is like $1,500.
$3.5 grand, I think.
Per each, right?
Yeah.
I'll make
pretty
you
sure they
one
were
cheaper.
expensive.
Yeah, so there's somewhere in the thousands per each.
That's gotta be the biggest racket.
Sherwin,
Yeah, so
Sherwin,
chrome plate hat, use a
NDT
punch
card,
on it.
I
I
guess.
mean,
Sherwin reference panel.
it's not like they have to figure it out. every
PSM-5,
single time.
actually, I remember now, it does say that, that's what it is, Sherwin
Chrome plate hat with
PSM-5.
it, fucking-
4,900.
not Sherwood Williams.
Sure, it will.
PSM is in PS, November, or PSM is in PS Mike?
PS Mike, PlayStation Mike.
Test panel. A TAM panel.
TAM panel, yes.
All right, here we go. Okay, that's not $675 to $840.
A little cheaper.
For one. This slide is in here because I used to have to explain to people what a nice booth looked like because we didn't have anything in the fluorescent. So, hey, look, if you had money, you could buy something like that. Guess what we have? Okay. And then I had to show what cracks look like because we didn't have the ability to do this stuff. But right there, that's a nice crack. Type. Type 2. What is it? See this blob right there? Can you see that?
Sat for too long?
Yeah, it's happened to
Yeah, it just start to blob out. You can't see the nice indication that's going to come through it is what you get.
Are there any repairs? I think I asked this already, but I forgot. Is there any repairs for when you find shit like that on cylinders and crankcases and shit? Or is it all just like scrap?
You talked to me.
Relevant.
a
I
little bit.
feel like you said this, but I forgot.
I guess the answer is for all your contemporary stuff, the answer is no, it's scrap. However, there are certified repair stations that have gone outside of the manufacturer and got FAA approval for weld repairs. So you can send it to a specialized shop who has received approval to do repairs that the factory has not authorized.
How much money are you willing to spend for it?
How antique is it and how irreplaceable is it? This is a nice one right here that shows an actual discontinuity. But you can see because it's such a low sensitivity, it only comes out in very small spots instead of one continuous line. This could also be an indication you would get with a press fit part. Parts that are press fit together naturally have a crack in them because they're press fit. There's a seam. So that's what a seam would look like. So you have to determine, well, is that just a manufactured seam or not? Why does that look like a towel? Probably is a towel. You guys will see stuff. Got the
So
TAM
would some of
panels.
those things kind of like pop up on the race of like a crankshaft or something like that and give a false indication too?
This? Oh, race of a crank? No, crankshafts are one piece. So,
Well, just because like if something got in between the bearing and gave enough of
yeah,
a scratch
nice
there.
scratch. This is a crack panel. It's not the kind of crack that you guys are probably used to. It's another type of panel that I did not get to see this or play with these, so I know that it's just another type of thing that has cracks in them. This is what it's gonna look like. I don't know. All right, we will finish this off tomorrow. We will talk a little bit about process control, just kind of repeat that and make sure that we're got it down. And what's tomorrow, Wednesday?
Alrighty. Alright, did you want me to do this?
Thanks, bro.
Okay.
Yeah, for sure.
Yes, that's right.
Will we still be able to do that?